Okay, let's talk AP Calculus, AB, specifically Unit 5. Right, so this should be everything you need to know for the test. I'm not going to really go over MVT because I mentioned it in another video, but I will be going over EVT. Basically, EVT is telling you that everything has a maximum and a minimum, right? And those maximum or minimums can be at the end of a function, right? So for example, this little graph I have right here, there is a maximum at b right here. This is the top of the equation. It doesn't get bigger than that for that function. But it could also be a minimum right here. So if you have an equation where it's asking you find all the maximums and minimums, or find the absolute maximum and minimum of an equation, you want to find all the critical points, right? I have a critical point right here and here because it's going from positive to negative or negative to positive. So I have to find all my critical points, and then I have to put it in a table, right? I have A, which is the left bound boundary, and then I have my critical points, and then I have B, which is my right boundary, right? And then I put those all into my calculator, or however I'm finding out these things, and I can find out what the max and the minimum are, right? And that's what I've done right here. The absolute max would be f of b, which is like 15, and the minimum would be f of d, which is like negative 10. That's how you'd go about doing that. That one's not too bad. Now you have your first and second derivative tests. This seems like a lot, but it starts to make more sense as you're going about it, right? Like these three ones are kind of obvious. F of x equaling 0, that means that f of x crossed the x-axis, right? No duh. F of x being bigger than 0, f of x is positive. F of x is less than 0, f of x is negative, right? Those ones are obvious, but as you get more and more like deriving, it gets a little bit more complicated. When when f prime of x is equal to 0, f of x is either going from increasing to decreasing or vice versa, right? So you either have a maximum or a minimum right there. This is what you call a critical point, right? That same critical point I was talking about over here. If f of x is positive, then f of x is increasing. If f of x is negative, then f of x is decreasing, or f prime of x for both of those. Now f double prime of x, if that equals 0, you have a point of inflection. That's when you're going from concave down to concave up, or concave up to concave down. When f of x is positive, you have something that's concave up. If you have f of x that is negative, that is concave down. Now, if f prime of x is equal to 0, and f double prime of x is positive, then you have yourself a minimum. If f of x or f prime of x is equal to 0 and f double prime of x is less than 0, then you have right there a maximum, okay? Because maximums only happen at concave down, right? And if it's less than 0, it's concave down. And the same thing goes for minimums, except roles reversed. Now, let's do this one, for example. We're looking for the horizontal tangent where y squared minus 6y minus 9x squared minus 144x is equal to 576, and y prime is equal to 9 parentheses x plus 8 over y minus 3, and the horizontal tangent is on the x-axis, right? So that's on the bottom one, this one right here. So we're looking for a horizontal tangent here, which means that the denominator of the function is not equal to 0, and the numerator of the function is equal to 0. So let's focus on just the numerator of our equation here. Now, if we're looking for the x-coordinate of the point here, because the slope is going to be 0 no matter what, right? If we're looking for the point, we already know that y is equal to 0. We just need to find the x. And the y prime has graciously given us that with 9 parentheses x plus 8. So we just set y prime equal to 0, and we get x equals negative 8. You put that into Khan Academy or wherever you're doing this, and you'll get the right answer. Now let's look at optimization. This is probably the hardest thing we're going to do because there's so many ways that it can be done. So I've just picked out an example from the whole thing, and I've done it all out. And I'm going to take you step by step through it. The question is saying, we want to construct a box with a square base, right? So that means that the width is the same for both. The material used to build the top and bottom costs $10 per square foot, and the material used to build the sides is $1 per square foot. If the box must have a volume of 10,000 cubed feet, determine the dimensions that will minimize the cost to build the box, right? So we're looking for an absolute or just a relative minimum. It'd probably be an absolute minimum too. So let's look at what equations we are given. 10,000 is equal to width times length, right? You have your box. It's square here and then up here. So it'd be width times length. Now, we have also the cost of the bottom and the top given to us, which is width squared, right? Length times width of the square, and we have two sides of that, so we have the times 2 right here. Now this times 10 is the times 10, or the $10 per feet right here, right? That's why that 10 is there. So we can simplify that out to 20W squared. Now the cost of the sides is length times width, right? Times 1, because it's $1 per square foot, and then times 4 because there's 4 sides of that box, right? Now the sum cost of these two things together would be 20W squared plus 4 length times width. You can also simplify this equation right here to just get L on its own. So length is equal to 10,000 over W squared. Now, if we substitute this into the sum cost of the thing, we get 20W squared plus 40,000 W to the power of -1, which means that we just have a W right here in the denominator. Now we need to find the derivative of that. And this is pretty simple, the way it's done so far, so it should be, pretty simple to find it out. You will get 40W minus 40,000 W to the power of -2, right? And now you want to set that to 0. And through that, you will find that W cubed is equal to 1,000, or W is equal to 10. Now we have here a critical point, and we have to test if this critical point is an absolute maximum or an absolute minimum. There's only one critical point here, so tuition would assume that this is going to be our minimum. But if you're doing this on a test, they're probably going to be like bums about it and ask you to prove that it's an absolute minimum. So this is what I've done right here. The SC prime of 1, which is less than 10, is equal to negative 39,960, right? And anyone can tell you, given that there's a negative number or a negative symbol right here, that it is a negative number. It is less than 0. Now, SC prime of 100 will get you 36. And given that there's no negative sign, we can assume that it is positive. And since it's going from negative to positive, right? It's going from decreasing to increasing. We can assume that there is a minimum there. Not an absolute minimum, could be a relative minimum, a local minimum, etc., etc. But the important part is that it is a minimum. And it's the only one they have there. So you can now input that W equals 10 back into that original equation right here, and you will get that length is equal to 100. So the dimensions of the box are 10 feet by 10 feet by 100 feet, right? That will be just the way you go about the question. It's not too bad, but it's also really that bad. Like, I spent 90 minutes doing these questions only to get 2 right. And this is the amount of work I've done for one question. And it's very important that if you're going to do these, you have to cross your T's and dot your I's, okay? Do not rush these. Do not try to do these in your head, okay? It's just better for you to just do that nice and slow. especially because these are going to be FRQ questions. These are not going to be, you're not going to get a multiple choice question asking you to do all this, right? That would be kind of crazy. But that's basically everything for Unit 5. I would really review my last video for Unit 5, given I was more adept with the topic, and also I didn't talk about the MVT here. So, yeah, with all that being said, good luck.